All right, everyone, welcome. Uh, as you know, I went to the Demuxed conference this year to get to know the latest and greatest happenings in the video technology area and also to use it as a networking opportunity. It was a really well organized event and highly informative, and there were a lot of engaging talks. The guys over at Mux made sure that everything went really smoothly. So a huge shout out to Matt and the Mux team for organizing the event. So for those of you who don't know, Demuxed is a conference for video engineers like this. If you don't recognize those hats, it's the logo for VLC, which is one of the most widely used media players. The guy on the right is one of the lead developers over there, and the guy on the left is uh, a contributor to both VLC and FFmpeg, and he's also the creator of the VP9 codec, which is used in YouTube to encode their videos. So before we move on, just like housekeeping, none of the content in this presentation belongs to me. It all belongs to our respective owners. And I mentioned the sources at the bottom of the slide. And I'm not associated with Mux or Demuxed in any way. And there are any errors in the explanation of the details. It's completely unintentional. All right, so now that we have that out of the way, if I have to describe the conference in a couple of words, I would say it was all about streaming, which makes sense because we are in 2018 and most of the media we consume is over the internet. So the conference was spread out over 2 days, and as I said, it was really informative. There was a lot of information to take in at the time, so I had to spend a couple of days after the conference just to digest the information. And I categorized the talks into these 5 labels here very roughly. Distribution seemed to be the most dominant, which again makes sense given how we consume our media. Another key area was playback, specifically measuring playback performance and how to improve the end user experience so they enjoy watching your content and keep coming back for more. So now that you guys have a general idea of what the conference was about, I'm going to go into some of the talks that I thought were particularly interesting and just to be even to be aware of. So the first talk was by guys over at the Fubo TV, who basically laid out what it took for them to live stream the World Cup soccer matches to millions of people in 4K HDR. So on the left here, you see the packager, which basically takes in the raw video and audio streams and converts them into a streamable format. Now, when I was in the conference, I wasn't sure what some of these terms meant, so I had to look them up later, and I found a couple of interesting things, which I'll talk about in the next couple of slides. But in the middle, you see the origin server, which is where the streams first end up before being pulled by the CDN and eventually to the end clients. Here they chose the S3 as their origin server, which they explained was not their first choice, but due to the ease of setup and compatibility with different vendors, this is what they decided to go with. So as I mentioned, I wasn't sure what some of these things meant. And during the research, I came across a couple of things. The first thing I realized was just how many different streaming protocols there are. And I'm not going to go into details on all of them, but currently the most dominant ones are HLS and MPEG-Dash. HLS is widely used in a lot of devices, most dominantly in the Apple ecosystem because it was developed by Apple. MPEG-Dash is an ISO standard and it's non-proprietary, and it offers a much richer feature set, as you can see from the list here. Unfortunately, Apple does not support MPEG-Dash currently, so people have to maintain 2 different sets of media files if they want to support both ecosystems. However, Apple recently announced that they would be supporting fragmented MP4s, which takes us one step closer to basically having a universal streaming protocol, because now people don't have to actually maintain 2 different sets of media files, but only 2 different sets of manifest files. So if I go back into the previous slide here, you see a bunch of acronyms inside the red circle. So the way a streaming protocol works is by taking the source video and segmenting them into smaller chunks. And the information about these chunks, such as where they're stored, what their bit rates are, etc., is stored in something called a manifest file. And that's what these M3U8 and the MPD files are. the M308 is for the HLS stream, and the MPD is for the dash stream. Hopefully in the near future, most people will be switching over to the dash stream, so people don't even have to maintain two different sets of manifest files. So what's the relevance of all this to Intercut here? As it turns out, the dash protocol is perfectly suited for source switching. So what that means is it's built with things like support for multiple camera angles, bit rates, resolutions, all of that in mind. So it's really easy to quickly process files and present them to the end user without a lot of processing involved. Here you can see the segments that are built up hierarchically. The periods are completely isolated, so you could actually switch the characteristics of a period when I switch from period n to n+1, for example. So if you're in the middle of a stream and you wanted to switch the bit rate, you could do that when you switch over the period. And the periods here can be anything from 1 second to 2 seconds or any other user customizable amount. All right, so the next talk was from Netflix, and they basically talked about how they built this huge infrastructure just to make deploying their codes at scale really easy. And they talked about a couple of use cases on what they achieved using this platform, and I picked out one of it just to keep it brief. So here you see the visualization for the Billboard artwork that goes on the Netflix show page. So if you're in Netflix and you're browsing through the show catalogs, when you hover over a particular movie or TV show, it expands to show you the title and the show card. So here the background was actually selected by a computer vision algorithm. And how they do it is basically they parse through thousands of images for every movie and TV show, and they basically the algorithm returns these bounding boxes of what it thinks are the focus areas. So, and after that, they're filtered based on things like there needs to be enough space for you to insert the show title and the card without blocking the main object, or the frame shouldn't be blurry, and stuff like that. I thought this was really cool. I always thought this was a completely manual process of how they selected the background image, but it's really cool. And I'm sure like for bigger TV shows and movies, it's still manual, but it's really cool that they're using stuff like this in real world use cases. So how do they do it? So they built this platform called Archer, which basically takes out all of the grunt work from the developer on how to deploy and maintain your code at scale. And what does it look like from the user perspective? The user here being the developer. So let's say you wanted to write a code to convert a RGB media file into a grayscale media file, for example. Now all the user has to do is write a couple of lines of code to convert the media files. And then what Archer does is it takes that code and it can run on any movie or TV show on Netflix, or even the whole Netflix catalog if the user chooses to do that. So basically the user doesn't have to know where the source files are located, what formats they're in, or even have access to the source files, which is really important because when you're dealing with sensitive data, such as pre-release content, for example, you don't want the user to have access to it. So the way it does it is basically it takes the source movie, it splits them into 2-second chunks, and then applies whatever the code written by the user was, and generates the output, concatenates them, and gives them back the output. So all of this is handled by Archer, and all of these splits are processed parallelly. So a whole movie can be processed in a couple of seconds. And I thought again, like this was really cool because it allowed Netflix to innovate like in new algorithms really quickly. All right. So the last topic for today is was also the last topic of the last talk of the conference, which was by a machine learning engineer over at YouTube. So he actually was not sure what he was going to present on until the last moment. So he hand drew his whole presentation on a tablet in a couple of hours, which is why you see this nice little artwork over there. So the rest of the slides are going to be like this because I copied the slides from him. All right. So what did he do? Actually, before that, I should mention, so his talk was really controversial because he basically said that video quality does not matter to a room full of video engineers, which gathered the appropriate response from the crowd. So what was the experiment? So if you've ever been on YouTube desktop site on the browser, you know that the YouTube videos start playing out in the small window. So by default, all those videos started at 480p videos. And if you go full screen on those videos, YouTube tries to give you the best possible resolution for your device. So if you had a 1080p monitor, it tries to give you a 1080p feed. If you had a 4K monitor, it tries to give you a 4K feed. What they did was they selected a number of individuals and artificially capped them at 480p. So that meant that even when they went full screen on a 1080p monitor, they would still see it only in 480p. And what was the result of this? Surprisingly, nothing, except for a really small 3% increase in the number of people who manually updated the resolution. There was no drop off in watch times or any other like things that you would expect. So, which was really surprising. So they had to run a couple more tests to confirm their findings. And before that, there's one more thing that I need to mention that YouTube does. Is something called sticky quality. It's basically when you're in that small window and you're watching a YouTube video and you manually select a higher resolution video, YouTube locks you into that higher resolution for the rest of your playback session. So even if you go to another video, it still plays in 1080p, even if you're in the small video. So this time what they did was they targeted these individuals. So basically what that means is there were some people in the original data set who were unaffected by the 480p cap because they had already selected the higher resolution session, basically. So this time they targeted these individuals who had locked themselves into higher resolution. And what they did was they gave them a 1 in 64 chance that they would be downgraded to a 480p resolution. So when if you were one of those people, you're watching your YouTube videos in the small window, suddenly on your 64th video, you might get a 480p video. And what was the result of this? And this was really fascinating because there were actually more instances of playback sessions manually being updated than there were the number of sessions that were broken, basically downgraded 480p. What this meant was that not only were people recognizing that there was a quality difference immediately and switching to a higher resolution, but also on each subsequent playback session because they didn't trust YouTube anymore because they thought that something was broken. They wanted to make sure that they were getting a high resolution feed. So what does all of this mean? It basically meant that people had segmented themselves into two categories. Those who cared about quality and had used the resolution selector, and those who did not care about quality and never used the resolution selector. A better way to think of this, as he rightly put it, was that almost everybody has a threshold about which they don't care about quality. But for a lot of people, this threshold is actually pretty low. And if we can understand that, we can actually provide a better playback experience to everybody across the board. And that's the end of my talk. Thank you, everyone.